NFT platforms out there. And we do it using IPFS, or the Interplanetary File System. And the reason a lot of these people use IPFS for a technical reason is you need to actually be able to prove what the file is associated with an NFT. So when you're talking about who owns the files behind the NFT, IPFS is really, really good at identifying the file and proving that it is what it's supposed to be. So.
Awesome. So for you, what is decentralized file storage? Why did you get interested in it? Why are you building on top of IPFS? And how do you see that developing in the next few years, specifically in the crypto space?
Yeah, so I think the most interesting thing about decentralized storage is, again, just kind of proving ownership. So you need decentralized storage with things like IPFS and Filecoin, and then you need the NFT that's actually showing transfer of ownership, or in some cases, licensing rights between people. So what's exciting to us is being able to prove that you own whatever the file is and being able to transfer that between people, whether it's an individual on a marketplace like Rarible or OpenSea, or it's actually between companies, entities, DAOs, whatever. You need to have a decentralized file storage system underneath. We run exclusively on IPFS today, and it actually has a massive, it has a lot, basically all NFTs in the space use IPFS first, and then they use something like Filecoin or other protocols underneath. And the reason they do that, and I kind of already touched on this, but the reason they do that is with IPFS, there's something called a content identifier, or a CID, that is unique to each file. And it proves what that file is, whereas with traditional file storage systems like AWS or any of those kind of cloud systems, you can't actually prove what the file is. So what happens is the file underneath can be swapped out, and there's actually been some great examples in the space of NFTs where an artist has actually created an NFT and then swapped out the file after they sold it for they sold it on OpenSea or wherever they sold it. And so people, the artist actually did art and then swapped out the art and put rugs behind it. So they called it a rug pull, which was interesting, but not very good for the people that are collecting these NFTs. And so with decentralized file storage, you can help prevent these problems in the space. And going forward, there's nothing necessarily wrong with swapping out content behind an NFT. You just need to prove and show that the content has changed. And so that's where decentralized file storage comes in, and where something like a traditional AWS or a Dropbox or any of these kind of regular file systems don't work, and you need a decentralized file storage system behind it.
So in terms of proving authenticity and really giving, I think, more power to the NFT holder themselves and being able to kind of really own that image, and like you said, there's been times where the images really are essentially completely changed. And a lot of these projects, even some big ones, still have the power to change the image that is tied to the NFT. Do you guys deal with that authenticity? How do you see that kind of resolving itself? And it seems as if decentralized file storage is going to support that, but how do you get almost like a governance component to it to not allow someone like the project managers, the project developers, to really have control over what is actually tied to that NFT?
Yeah, so the way it's solved is, again, going back to this content identifier, the CID. It's a really important concept that many people aren't aware of. Luckily, most NFTs have this CID embedded in them, but to go back, I should actually start with NFTs are a token on a blockchain, and then the files have to sit somewhere else. And the reason for this is because if you were to store data on-chain, like actually on-chain, it would cost, like if you stored it on Ethereum, it would cost millions of dollars per gigabyte to actually get that image or that video or that application on-chain. And so you need somewhere else to do it. But if you did it on AWS, they have no way to prove that this file is what it's supposed to be. So that content identifier basically IDs every single file, whether it's an image, video, application, any kind of data set, that you can upload to IPFS. You can generate that CID. That CID gets embedded into the NFT, and then that CID is always associated with that NFT moving forward, and everybody can look at it, and everybody can verify that they are getting back what they're supposed to be getting back. Now, from an NFT, like an art perspective, it allows you to ID that you're getting the right art, but it also helps at a larger scale, like in the metaverse, or as we're building out these complex systems. It allows other applications to read the content and rely upon it, and make sure that they're actually giving you, the right 3D avatar in your metaverse world, and they can just pull from that extremely easily. So the space is kind of already solved for this by using IPFS and CIDs and embedding them into the NFTs, and it's a pretty standard practice. And then moving forward, you just need to kind of like verify that you trust who actually minted the NFTs and things like that. But it's definitely part of the solution in the stack.
So and for you, and it's very rare to see these types of companies. You offer like monthly packages in terms of being able to provide gigabytes of
Yep.
data storage, and it's very affordable. The monthly pricing. How are you able to have it be so affordable? And do you run your own infrastructure? How does that work?
So Pinata runs IPFS infrastructure. We have hundreds of nodes across the world where we're running this infrastructure that people can rely on. But actually, one of the interesting things that maybe people don't think of is files don't have to last forever, and NFTs don't actually have to last forever. And it's usually a hot take when I talk about it. But hey, welcome. And so what we really love is thinking about how NFTs can exist for certain amounts of time, whether that's less than a second or for long periods of time. And that's actually the most interesting question we deal with working in the NFT space is how long should these files actually exist? And it becomes pretty complicated, but I'll stop and have him jump in.
Yeah. Should I borrow the mic? Hey, sorry. So I work on IPFS as well. I actually work for Protocol Labs. We make IPFS and Filecoin. And I think, to Cal's point, it's like a really difficult question. I think permanence also can be somewhat of a meme. I think there's a question of like, what are the guarantees that you have? If you think about the internet itself, like how long have we had the internet? For 50 years? Even like blockchains, how long has like Bitcoin been around? I think the moment we start thinking of like how do we get to permanence, there's a question of like what are the ways that we plan for failure modes that might happen. Closer? Yeah, I mean there's just a question of like how do we plan for all the different failure modes that might happen. So I think if we start thinking about what does the future look like and how do we actually ensure our content is persisted, it starts with how do we have the right primitives to make sure that as the world changes, as things potentially go wrong, we have mechanisms to recover from. And so when you have something like a CID, it's not mapped to any one specific economic model. It means that you can recover from any different storage layer that you might want, whether it's coming off of something like Pinata, whether it's coming off of a local hard drive, whether it's coming off of a different decentralized file system. And so I think all of these things are really just thinking about how do you architect your NFTs in a way that are future-proofed, and then solve separately for how do you make sure the content is persisted in perpetuity. We already have interesting other tools. You can have DAOs that have DeFi, like with treasuries, that generate yield and then use that yield to go fund the actual storage ongoing. But I think at every different stage, the thing that matters is being able to say, for sure how many different copies I have of my data, as well as I know for sure that that data hasn't gone offline, and if something does happen, something can just programmatically behind the scenes in a very like Neil Stephenson sort of way, just like happen and just like execute.
With Protocol Labs, when it comes to what you guys are focusing on and what's most exciting within the decentralized file storage ecosystem, what are the things that excites you the most within that space?
Yeah, I mean, obviously, so the way that we think about this is we want to solve different problems at different layers. So I think the IPFS layer is really about how do you create permanent references to content so that regardless of where it is, you can always add that content back and serve it. Then separately, if we want to solve for permanence, the thing that we really care about is making sure we get the right guarantees. So we build Filecoin, which is a blockchain protocol. But really the way that Filecoin works is we start from the first principles of what are the error cases that we don't want to happen. Well, we don't want to have people drop data off the network, so we want to make sure people have skin in the game, that when they have your data, they too want to stay online because they will lose money otherwise. So like the Filecoin protocol literally is just enforcing a cryptographic SLA. Miners will put up money, that money is up there, and if they don't prove over every 24 hours that they're still holding your data, they will lose that big pot of money. So even if like the token price goes around, falls down, all of that stuff, miners stay online with your data. The other important point then is how do we make sure that someone is actually doing the thing that they say that they're doing? In our case, this is where we have cryptographic proofs. We can say, every 24 hours, I want to know verifiably that your content is still there. I can see that this is happening on a consistent basis, which means you have this chain of custody that you can actually follow on a blockchain and say, at any given point in time, I know exactly how many copies of my data exist. I know that they're still in good health. And if something goes wrong, there's something I can do to save my data. And in this case, doing something could just be programmatic. It could be a smart contract. But it's really just about making sure you have those right primitives that allow you to take the right actions.
Pinata is really building and using IPFS, not Filecoin. Why, I mean, is there a reason for that? Do you foresee yourself using Filecoin? How does that relationship work?
Yeah, so for us, we actually work closely with the Filecoin team with their Nft.storage, I guess, product or system. And so we think that Filecoin is a great use case for us, and we can use it to basically store the files for us in a decentralized and inexpensive way. The reason we're focused on IPFS today is because basically we think of ourselves as like the hot layer of serving content. So there's the storage of the data and making sure it persists and is around when it's supposed to be. But then there's also like, you want that video to show up on your mobile phone as quickly as possible. And IPFS is really, really good at that. It's really good at serving content quickly, getting it to the people as quickly as possible. And as these applications of NFTs get bigger, when you're serving full games or large videos, that becomes really, really important as we're trying to speed up and improve the experience for the end user of these applications. One thing I would love to add, though, is there was actually an example where a developer had built a NFT marketplace called Hen, and this happened a couple weeks ago, where they decided to just kind of like exit out of like supporting this marketplace, and the community came together, and all of these NFT artists and creators came in and actually saved the art, the NFTs, the images, the videos, whatever they were creating for this Hen marketplace, separate of the creator of the marketplace. And so with IPFS and Filecoin, you were able to, in that CID that we've mentioned multiple times, you were actually able to prove and save all of the content behind these NFTs and come together. And now that the community has actually come together and all supports these images and these files because of IPFS and Filecoin.
When you're storing a lot of these files, and you mentioned that for a lot of these NFT projects, they're actually much more short-term in terms of the storage. What happens when people stop paying, or what happens when the NFT project kind of dies down? Does the files disappear? How does that work?
Yeah, so I actually wrote a blog about this in 2020 called "Who is Responsible for NFT Data?" And the way I framed it was, is Da Vinci responsible for the Mona Lisa today, 500 years later? And the answer to that is actually no. The Louvre Museum is the people that are taking care of the Mona Lisa. And we kind of think of NFTs and the image or the files behind it in a similar way. And so the way we look at it is when you are minting an NFT, as a creator or a marketplace or an artist or whoever's minting these tokens, You just need to figure out who's going to be responsible over the lifetime of the NFT. Now, with things like IPFS and Filecoin, you can make this really easy to transfer the responsibility of the files behind the NFTs over time. And so it can actually transfer from the minter or the marketplace that started it to the buyer, or it can be warranted. So maybe a game NFT decides, hey, we're going to support this NFT for 5 years. We're going to say that up front. After 5 years, if you want it to continue to live on, you can take over the costs associated with it, whether it's on IPFS or Filecoin, and you can transfer that responsibility through the CID. We think a lot of this is going to happen, behind the scenes. It'll be kind of pretty much automated. So like an end user or a gamer that's buying an NFT isn't going to have to worry about this stuff. Taken care of on the infrastructure layer, but that's kind of how we see this happening in the future.
Maybe just to add on to that, I think one of the cool things with CIDs is because, as Kyle said, we can like transfer ownership in a sense of like anyone could choose to support any specific CID. I think that also really melds in a really nice way with crypto, where we have these tools for capital formation. And when we start thinking about DAOs and like, if you have a community that's formed around a set of NFTs, like, yeah, it would make sense to have a DAO where you're able to just put capital to work to make that happen. I think from like the disconnect that we sometimes have is people can think that, oh, well, who pays means that we have to have this answer where it's like there's a person, which means then there's centralization, there's all of that. I do think the cool thing when we start thinking in crypto land is we can have tools that are just, they're smart contracts. There is a fund that automatically is getting yield by depositing it in something like Compound, and then using that yield to actually like pay off the actual ongoing costs that are happening behind the scenes. So from like the perspective of a user, you can still get something that feels like, oh, I've minted the thing, it's like happening. But like at the end of the day, there are like disks that are spinning, there's things that are happening. So it's like there aren't smoke and mirrors here. There's tools that we have that can make this stuff actually happen though.
And one thing I'd love to add is the person that cares most about an NFT, or the entity that cares most about an NFT, is the one that owns it, right? So whether that's an individual or a DAO or a game, whoever owns that NFT is going to make sure that it lives on and is going to care for it, right? And so moving forward, we think that kind of idea will move across the space and become pretty standard.
For Jonathan, what is the relationship with IPFS and Filecoin? Clearly it seems like IPFS is the technology. Filecoin seems to be it's more of like the reward mechanism to build an ecosystem on top of IPFS. If you could describe that relationship and kind of how you see Filecoin playing out and really how you see Filecoin growing within that ecosystem.
Yeah, I think it's interesting to think of them more as like complements to each other. They're two separate projects. They both speak a lot of the same languages, but that's sort of like kind of how Protocol Labs builds our protocols. So IPFS itself is like a standalone protocol, and the way to think about it is it's a way of storing and retrieving content based on a fingerprint of the content. And so that's totally open source. There's no economic model behind it, and that's actually a feature, not a bug. In that sense, like if you have something that's using IPFS, you could store it on as many storage layers as you'd like. I'm a storage layer maximalist in the sense that like just put it everywhere, like S3, Filecoin, Arweave, wherever, it doesn't matter. IPFS gives you this ability of magically saying, hey, internet, I would like some data. Here's the fingerprint of that data, and then the internet can give it back to you. The thing Filecoin tries to do is solve a different problem. If IPFS does all this hard work to make sure if there's at least one copy of your data on the IPFS network, it will find it and bring it back to you. Filecoin solves for the 0 to 1 problem of how do I make sure that there's some copy of that content on the network. So Filecoin as a blockchain protocol, really it speaks CIDs, it does all of that good stuff, but it's really caring about how do we make sure that I can give you deterministic guarantees around the persistence of your data. And to do that, we do a lot of really cool stuff with like cryptographic proofs. We have like the largest ZK knowledge or ZK like zero knowledge proof like proving system, both for like when data is ingested to know that your data, like the actual version of it, is the thing that's stored, as well as proofs over time to see that that content's there, which gives you this chain of custody that you can verify. And like the interesting part about the verification is really just so that programs can start doing more of the heavy lifting to make sure we have redundancy, resiliency, all of that good stuff. So yeah, I mean, the way to think about these are IPFS, especially for NFTs, is like a really critical technology because it gives you the flexibility to swap out storage layers without your NFT breaking. If for some magic reason there's like a bug in one of these other protocols, you don't want that to break your NFT. Like IPFS gives you that like guarantee that like the thing that you're referencing is immutably your content. And then you can pursue downstream all of these other like economic models, whatever you'd like, in order to make sure that the content is actually persisted. We have like strong confidence in Filecoin, obviously, but yeah.
So I think we'll just do a quick one-sentence final question. Is what excites you most about the decentralized file storage sector in the crypto space?
Yeah, I guess since I have the mic, I can go first. I think we're like just getting to the very beginning of what we can do with Web3 technologies. I think like a way of thinking about Amazon as a company is Amazon is a business. It has like, I mean, it's many businesses, but like if we just think of the cloud side, it's like they have all of the engineering side, and then you can think of it as having like a finance department. The interesting thing about protocols is slice this entirely differently, where we have an open storage market where anyone can participate as like a storage provider in order to like go provide their services to this network, and the protocol itself is ensuring the quality of that storage. It guarantees for the user that whoever putting their storage capacity on the network is all going to abide by the same terms and services of what quality of service and making sure the content's there. What's interesting then is when you start thinking about what is the role of things like DeFi, it's like having that financial department, but can go to any data center that's like operating on the Filecoin network, any individual who's operating with that capacity. And so I don't think we've really started to see what it means to have these things like unbundle and rebundle in the Web3 space. But like the thing that gets me super hyped is when we start thinking about, okay, well, what are other ways that we can pay for data and how can we pay for storage? Like we can do all of this value transfer that normally happens through like Wall Street and other things, but do it on chain and use it for productive services where it's like, how do we actually make the cheapest cost of storage? If we want to have the metaverse with like petabytes of data, like what we want is to have systems that can actually scale with that, and also have financial systems that make it accessible to as many people as possible. And so like having things like DeFi help subsidize the cost of storage, subsidize the cost of access, I think is like the most powerful idea that I've had in the last year, where it's like, this is all different things that can make the internet more accessible, number one, but two, more resilient. Like we can have these things actually be verifiable. We can see like if Yahoo Answers is gonna go down, how do we make sure other people can like come in and save it? Same for like Hen, but yeah.
And then for me, what I'm most excited about is just to see what developers and creators can do with these new technologies. Like Jonathan said, we're really early. We don't necessarily know what it's going to look like exactly, but very creative, software engineers and people moving into the Web3 space are trying to apply this to absolutely everything. And I think it's going to end up creating some really unique applications that we haven't even thought of yet.
Awesome. Thank you, Kyle. Thank you, Jonathan. And thank you, everyone, for tuning in and listening.